All right, thanks for joining us today. As you see on the screen, we have a few things coming up. Mid-Atlantic chapter is holding their holiday social on Friday night, so that's going to be a fun event. Our next new member quarterly roundtable will be on January 14th, and I go through all of your member benefits. So whether you're new or you've been here a long time and you want a refresher, I encourage you to join me. Our next month's MBCEA Presents is going to be specifically targeted at your sales teams, your regional district managers. We want to make sure they know everything about MBCEA, who we are, whether they're a member yet or not, if they belong to a chapter yet or not, they can join. And we want to make sure they know all the benefits for their builders as well, how they can look like the expert on so many different subjects other than just your product. So that's January 15th. And conference registration is also open for our April conference. So we encourage you to register now for that. And I will now turn this over to our presenters.
Fantastic. Thank you, Sasha. Let me go ahead and share my screen. Can you see me okay?
Perfect.
Fantastic. Fantastic. Well, thank you, obviously, for the attendees for jumping on. Today, we'll talk a little bit about cold form buildings. Did want to say thank you specifically to the MBCEA for allowing our participation today. Um, I know Sasha mentioned it, but just a lead-off reminder, the 57th annual MBCEA conference that'll be held in Colorado Springs, April 22nd through the 24th. I know she touched on the app. Feel free to visit the website, obviously, if there's some interest, any questions about that. Leading off introductions, I'll go ahead and kick us off here. My name is Cameron McPherson, North American Sales Director of ACT Building Systems. I'll give you a little bit of background about myself so you kind of know who you're talking to. I had joined ACT in March of this year, so approaching a year. It is very quickly moved by so far. But previously, I'd spent over 10 years in the steel component building or steel component business, held roles in field sales, product management, and regional management. Before spending, I had a few years outside the industry where I worked for an irrigation manufacturer for about 3 years. And so now I'm back with ACT. I say back with ACT. Now I am with ACT. Um, my introduction to ACT and more importantly, cold form buildings really occurred during my tenure as product manager. That's when I was first introduced, I think, to cold form in general. And it admittedly, again, we're talking 10 years plus ago at the point. I had my own skepticism, but quickly realized what the overall market opportunity looked like for really all parties involved, right? So your buyers, erectors, sellers, and at the time, in particular, manufacturers. So really excited to talk a little bit more about cold form, the cold form space today, what we're seeing, and how it's going. So we will hope we're going to hold off on questions until the end, and we should have plenty of time. So we hope to answer as many questions as possible. But both Nathan and I will have our contact info on the screen. So if anything we can't get to, we'll certainly follow up with you without question. Want to obviously turn it over to Nathan of Natmar Construction. Nathan, give a little background on yourself so folks know who you are.
Yeah, my name is Nathan Margosian. I'm the owner of Natmar Construction. We're a metal building distributor and erector. I'm also a general contractor over on the western slope of Colorado. My main experience with cold form is when I started getting into the business on the erection side, working for a couple other companies prior to starting my own. A lot of what they did was cold form. They were mainly in the residential sector. And so that's been a big staple for my business at the start and continues to be so today, even moving more into the commercial space. So yeah, I'm just excited to talk to you guys more about the cold form steel buildings, the pre-engineered metal buildings that they can be from the perspective of an erector and a distributor in my experience dealing with the end customers. So yeah.
So Nathan, far more interesting than me, but we will kick it off. We'll get to some of that, and obviously we'll have some conversation to go along with it. So, what is a cold form building? We'll start with the basics. Cold form buildings, pre-engineered metal buildings made up of roll form Cs and Zs, right? So they can be galvanized, primed, or painted. Specifically, components again, they're cold rolled. It's cold rolled steel that forms the shape of the C or Z. No heating or welding, obviously, in the manufacturing process. Sections are bolted or screwed together to form the structure of the building, including but not limited to portal frames, columns, or rafters, right? So the frame makeup, all lightweight but strong, precision manufactured, as previously mentioned, with your galvanized, primed, or painted finishes, corrosion protected as well, right? So um, pretty important. Cold form buildings in general. So what you're going to see, it's typical that you might see a column configuration using two. In this case, as you'll see in the photo, bolted back-to-back C purlins to form, if you will, an I-beam, right? There are additional framing members that will ultimately connect to that column. Bolted or screwed connections is what you're typically going to see. Back-to-back one piece, I did want to call out, I know we're showing it in the photo, but it really isn't a standard. It's going to be specified based off the engineering requirements, building design, etc. So it would be plenty normal, plenty typical to see a single C for that column in that instance. And then final note, no welding is required on site. As previously noted, all of these are going to be bolted and or screwed connections. That's going to vary based off building type, building design type, etc. Maybe engineering requirements. You might also see that combination dictated by the manufacturer's installer-based preference or potentially manufacturer's limitations, that they're really focused on. So one piece, as you're looking at this, you're looking at the connections, these back-to-back Cs, obviously certainly would suggest to familiarize yourself with those details prior to install. I'm sure Nathan will talk a little bit more about that as we get into it. Additionally, here we're looking at a list of features that can be easily added. I think from the metal building side, most of you are familiar with these, right? And so we just want to call them out on the cold form side and make sure you're aware these are these types of details or types of features adapt very well in a cold form building, opening for doors and windows, mezzanines in particular, partial or full. Very easy from a design aspect to incorporate that into a cold form building. Open or close lean-tos, wraparound porches, overhangs. Again, all features that you may be used to, but want to make sure you're aware that obviously they're available in the cold form space as well. And more often than not only available, but very feasible and easy to incorporate in the design. So looking at advantages of cold formed. So manufacturing in particular, how is manufacturing an advantage? These are all, as previously mentioned, cold rolled or roll form components. You've got a picture there on the right, obviously, of a purlin mill with some of the finished product. Gauges are going to vary from 16 to 10 gauge, with widths of C purlins now produced up to 24 inches, which a 24-inch 10 gauge member is a pretty sizable member, right? Primary advantage, overall throughput. Again, roll form components, no welding. You're really looking at it from a manufacturing standpoint, cost per ton or cost per man hour. That, roll forming obviously provides a pretty significant advantage. I'm not an operational expert. I am a sales guy through and through, but I've spent time, obviously, as product manager, working with operational teams and specifically roll former acquisition and implementation. And so I've seen that market, or at least, roll former manufacturers, obviously they continue to take strides and steps in the forward direction when it comes to what they're capable of, as well as automation, right? And I think we're going to continue to see AI play a role. And my expectation, or that improvement expectation that I see coming with that, is going to be the overall output and what that expectation is, right? So improved manufactured parts, C and Z shapes, holding spec, right? Twisting, I know, can be an issue, obviously, on some secondary framing or cold rolled steel, hole punch accuracy. So I bring that up just to say we've already seen it, and we're continuing to see significant advancements in that space. Another piece that I think some of you may have heard this story, but we'll bring it up again just from a sheer scale standpoint. Um, for example, today that we see manufacturers that are producing a building a week, right? At the same time, there are manufacturers that are producing up to 220 buildings per week. They are in Australia, where this type of construction is very common. That manufacturer in particular, I think there was, or a manufacturer in particular, was producing 186 buildings in one 40-hour shift, just to give you some perspective, right? So that's roughly 13 minutes on average to produce a building. So I bring that up just as a comparison, right? Generally speaking, those guys are set up. That is their core business. That's what they're doing. They'll have 3 or 4 purlin mills lined up that are specifically producing 6 to 8 inch, maybe 10 to 12 inch, right? Purlins. And then they'll have a line that's dedicated to roll form PBR, limited color selection, right? So they are really truly, limiting that changeover and maximizing that throughput. So I bring that up just to say, hey, it's not necessarily a pipe dream. It's happening today as the industry continues, to advance in the cold form space. I think we're going to see that proactive approach to manufacturing, move forward here in the U.S. as well. So building sizes, this is I say a very common question, if not the most common question that we get is, hey, what is the clear span that you can run with a cold form building? And that's going to vary, but generally speaking, as a summary, clear spans up to 90 feet, eave heights up to 32 feet, and then building lengths are virtually unlimited. The largest building that I'm aware of or we've been involved with was a 132-foot wide clear span, virtually no snow or wind loads, right? So your loading on that building was minimal, if not zero, right? But that building ended up utilizing two 20-inch back-to-back C purlins as the primary columns. That was 10 gauge material. So again, back to some of these larger Cs that are now being produced obviously can net and generate a little bit larger end result. And we've seen that, right? Over the past decade or so, we've seen that change from that, standard building size or that clear span expectation. New purlin mills come online with added capability. You start to see the buildings get a little bit bigger. So protection against the elements. I think this is a great slide for obviously metal buildings in general, but holds true with cold form buildings. Fire, obviously, building with non-combustible materials. I think that's a big one. Nathan, I'll probably have you swing in and maybe add a few comments to that. But water flooding, mold, termites as well. All advantages of building with steel as opposed to alternative methods, right? This house 7,300 feet above sea level, 30-minute drive on dirt roads to a fire station, right? So from an end user perspective, a great solution to provide some peace of mind. And Nathan, I don't know if you've got any practical application or some things that you've maybe walked through specifically that you want to touch on here.
Yeah, yeah, and I won't get into too much detail because we do have how cold form works with some insurances later on in the presentation. But I will say that here in Colorado, we've had some record-breaking wildfires this year. We've had in 2025, we've had about 218,000 acres of land burned due to wildfires. And because of that, we've seen a huge increase in demand for metal framed barn dominiums. I think cold form is a really great option for that customer base and to fulfill that growing need because it is, like Cameron's mentioned, and we all know, right? Metal, non-combustible material also helps with some of the specific coatings going into recent code changes in certain jurisdictions with siding above grade and that kind of thing. Um, so yeah, definitely growing demand specifically because of fire in places like Colorado, California, and we'll get more into that a little bit later.
Cool. Thank you, Nathan. So wind speeds in particular, I say to give a little bit of backstory on, cold form has been in the U.S. obviously for multiple decades now. There has been obviously, say in Australia, New Zealand, this is a very common type of construction and has been for a very, very long time. they're constantly exposed in those areas, right? Constantly exposed to cyclonic regions. So designing to meet higher wind speeds is pretty critical, which has allowed cold form to perform well in states like Florida, Texas, and other coastal regions, right, where wind is a primary consideration. I'm not sure this house here was designed for wind speeds to meet up to 170 mile an hour winds. So I had a stint in Florida, understand the Florida building code, right? I'm not sure if this is Dade County or if it's somewhere close. Obviously, I would expect probably somewhere pretty close to the coast at 170 miles an hour. But generally speaking, I think point being, these buildings are being designed to 110, 20, 30, 40 miles an hour on a regular basis and withstand without issue. Additionally, some of the loading, I think it's just important to touch on a cold form building is a pre-engineered building, right? So it's going to adhere to the same loads as a traditional metal building would, or it's going to have to. So a 40-pound snow load on a rigid frame building is going to be a 40-pound snow load on a cold form building, right? So your design can change. Base basing on cold form in a 135-pound snow load certainly probably would tighten up a little bit, right? That would be the expectation. But point being, loading is all taken into account. It's all addressed and managed. Another point, Nathan, I'll pull you in here if you had a second. I know we mentioned collateral loads, also deflection limits. I think you wanted to jump in and maybe talk to that a little bit, as that's something that you have to deal with on a pretty frequent basis.
Yeah, I just wanted to emphasize the ability to do the collateral loads and adjust the deflection limits like you can in a traditional red iron building. And I just wanted to emphasize that to set it apart from, because I think sometimes cold form can be grouped together into the tubular space. And it's not that. It is fully engineered to whatever you need it to be engineered to. And especially when we're talking about barn dominiums with deflection limits, you don't want to be breaking your drywall on the inside for the interior finish outs. We'll also talk a little more about that later. Um, and then again, the collateral roads when you know you're going to be finishing out insides, hanging lights, stadiums. You have heavier equipment. You got cranes operating in there for mechanic shops. You can adjust for those things in cold form buildings. There's a lot of there's pretty robust software out there to make sure that your cold form building is designed to what you need it to be. It's not just a generic, yeah, it's kind of in this classification of snow and wind, like a tubular building is. And then beyond that, the rest is up to you to either guess or modify on your own. It's pretty full service when it comes to the engineering side of it.
So how are those loads managed essentially? Typically speaking, right? Or generally, you're going to see X bracing, knee and apex braces, moment frames. I know, words, terms, ways to manage any sort of loading, pretty typical, as well as sheeting diaphragm, right? I think that's going to typically vary by manufacturer if they have the diaphragm testing complete. But these would be the primary ways that those loads are being managed within a cold form building. As you'll see, obviously in the photo, you've got strap bracing or X bracing, as well as knee bracing on a double column there. So essentially double knee bracing as well. So Nathan, I will turn it over to you for some of the construction discussion.
Awesome. Sounds good. So the construction, like Cameron had mentioned, you got columns, rafters, purlins, girts, a lot of the same terminology as you would in a typical red iron or hot rolled structure. It's not going to be too dissimilar, um, but there's some key benefits that I think shine with cold form as opposed to the heavier red iron. And I say heavier because the weight is going to be one of those big benefits. Cold form buildings, they're just lighter. And again, like they're engineered, I want to emphasize again that they're engineered to the same specs, whatever you need them to be. It doesn't mean that the building structure itself as a whole is weaker, but the individual components and pieces that you're going to have to handle in the field are significantly lighter. Some people build these entirely on scissor lifts. I know of a couple of cases where people are building more smaller DIY which is good for a distributor, right? To hit that market base. Customers building them, just like homeowners just building them off some ladders. Personally, what I do is I have a telehandler and I've got two scissor lifts. They go to every job site, and then for larger ones, you can bring in boom lifts and things like that. But it's lighter, it makes it less risky, less dangerous to work with. You need less equipment to work with it. The big thing here for me is going to be no cranes, right? You can get pretty decent sized cold form buildings without the use of a crane, which brings your costs way down and your logistics just simpler. So yeah, that's a big thing there. Then oh, there we go. Another big thing that I really like with cold form buildings, the software that I use for designing them comes with the anchor bolts, which most red iron uh, they don't come with the anchor bolts. You got to source those other ways, and they're often the wet set J bolts, or you got to anchor them afterwards with epoxy, but very commonly the wet set J bolt style. Uh, I think we've all ran into problems on the erection side, specifically if you don't do your own concrete, of those bolts not lining up exactly where they need to be. And when you have a building that is designed very specifically to be put together um, to its plans very accurately, that can be a little bit problematic. So one of the things I really like about the cold form buildings is you can lay out everything on a grid with your chalk lines, and then you can dry set. So you drill in and then use a Tapcon style screw down anchor bolt for all of your column connections to that foundation. It just makes that whole process of making sure your bolts are exactly in the right place, they don't shift during the concrete pour, or trusting your concrete guy if you're just erecting it, that they did that accurately and you don't have to worry about making modifications if it was done inaccurately. So it takes that whole side of it, which is just fantastic. And then a big thing, again, going back to the weight of cold form steel versus hot rolled steel, is the foundations don't have to be engineered quite as heavily to accommodate for the weight of the framing material itself. So a lot of times what we're seeing is we get about 30% decrease in your foundation costs because of that. You don't have to accommodate for these giant heavy columns with lots of concrete reinforcing, deep set piers, all of that. So yeah, that's between the bolts being set where you want them to be exactly in the field, not relying on other trades to get that accurate for you, and the cost down for the end customer from especially from a distributor standpoint or a GC standpoint where you're selling the whole package. That 30% makes a big difference because along with the building itself, the foundation is going to be one of your larger costs with a project. So then learning curve going into cold form buildings. For new erectors that are coming from wood or tube frame, I'd say the learning curve's pretty short. And it's even shorter for someone coming from a hot rolled perspective because again, you're dealing with the same components, the same terminology. There are some slight differences, mainly in bracing and clip connections. But a lot of the softwares now, they come with some pretty in detail details on their construction package plans that specify those things. And I think you get someone who has some familiarity with metal buildings, they do one of these and then, they're off to the races. I think it's a pretty quick turnaround. And again, if you don't have to deal, if you got a crew that's used to having to bring in a crew and now, or I'm sorry, a crane, and now they can just fly in all the rafters with the telehandler, that just speeds up the process even more.
And I would say I say add to that too, Nathan, because I know you still today put up both. I think if it's especially with cold form in general, just really understanding probably before you jump into it, know what the details look like, right? Know what you're going to need on site. If you have questions, ask those questions, right? There are plenty of resources that have dealt with cold form in general that certainly would be able to help out.
Yeah, absolutely. And like Aaron mentioned, what we do now is we build all sorts of metal buildings, cold form, hot rolled, whatever it is. If it's steel, we'll work on it. And there's no like the difference in time between one or the other really just comes down to the building and its size, its location, how detailed it is, all the options that are in it. It's not like if you've got some red iron guys, they're gonna come over and do a cold form one. The first one will take a little bit longer because they're learning that system, like Cameron had mentioned. You do that work on the front end, prepping for it with things like the clips and bracing specifically. And once you do it one time, then you're good to go. And you can easily get a crew that's used to the red iron side accustomed to the cold form side quickly. Yeah, and then the flexibility for cold form usages. I mean, we use them for uh pretty much all of our or a lot of our building styles, except for the very largest ones. It's not at the point at least yet where you're gonna clear span crazy distances. You're not gonna build your Walmarts or your Costco's out of it, but you hit that you can still do commercial buildings. Like we do a lot of climate controlled storage facilities and where I'm at, and those have been all out of cold form because they can hit that size of a storage facility, of a business park, of smaller horse arenas, equestrian, different larger commercial agricultural buildings. And but you can also use it, and it's cost effective enough to use it on the residential side for even just someone's secondary garage or barn dominiums or just some extra storage for someone. Probably not the best for the super small, like, you want like a little 4x8 like garden shed that you can get off of Amazon. Then yeah, that then it doesn't really make sense to go with a cold form building. But any actual structure, um, yeah, it does great. And then again, going back to the engineering, like it is a fully engineering capable structure. So like you can make it whatever the sizing you need it to be, and then whatever the engineering codes you need it to stand up to, you can design it to those things. So compared to post frame, obviously this is a metal building contractors and erectors association. So I won't spend too much time focused on the wood, but all the same advantages that you get, or many of the same advantages that you get for red iron as opposed to wood. You get, and I keep making that comparison to red iron because the assembly of it is very similar. Um, but yeah, it's pre-cut, pre-drilled components. You get the engineering. You're not making stuff in the field and hoping you pass the code or have to have someone on site that is going to pass your framing inspections and your codes. Everything's already stamped and ready to go. If they can read the plans, follow directions, then you're good. And of course, the larger clear span and the overall strength. So compared to a tube frame, again, biggest thing is going to be the engineering on it. It's the engineering. You can have more customizability with it, like Cameron had mentioned, with all the various portal frames. The mezzanines is a huge one. Just being able to go in and click some buttons and design something fully engineered with the mezzanine built in, that's pretty fantastic. Especially again, barn dominiums and like the business park for those clientels where you're going to see a lot of of mezzanine usage. It's a lot less material to install because you can still have those wider or those greater base spacings as opposed to a tube frame structure where you're, every 5 feet. You can go, a lot of the ones that we've done here are 20 feet. So there's less components to install, less components to manage. The engineering, again, massive, and then just you can just make them bigger, you make them stronger, you get the stamp plans with them, including the collateral loads and the ability to adjust deflection limits. And yeah, yeah. So compared to red iron, hot rolled, again, you have the lighter frames, but it's still engineered to those same codes. So you still get the overall strength without having the need for all that equipment. You have everything still bolted together. There's no welding on these, which Cameron mentioned earlier, which is also fantastic, keeping your labor costs down and just speed of process in the field as well as in the manufacturing facility, because again, no welding there. You can even pick on leading cold form design softwares, whether you want the building to be more bolted or more screwed together. So if you have a picky erector who's concerned about one or the other, you can actually choose how you want it to be assembled. And the biggest thing though is going to be that speed to site, right? So we've got a couple Red Arm buildings on our docket for 2026, and they're taking, 12 to 16 weeks on average from placing order to getting material to site, right? With cold form buildings, a lot of times you can get them in a couple of weeks. You can get stamped engineered plans in a couple of days, and then you can get the actual full building package to site in uh, 3 to 4 weeks, depending on what manufacturer you're going with, where your location is, how busy the season is, all those other factors. But even if you double that and you say you're at an 8 week time frame for a cold form building, which all of my previous orders have gotten to site much, much quicker than that. But even if you double that high end of the 4 weeks, put it at 8, you're still half the time of what the average hot rolled building is. And it's because of the advantages it has on the manufacturing side. Like Cameron had mentioned, that one manufacturer in Australia who's pumping out buildings. What was the average? 13 minutes?
13 minutes of building. Yeah.
Yeah, that's
Yeah.
just crazy.
Right.
Which helps a lot on the distributor side. So if your distributors and your salespeople can talk to a customer, as a lot of these end customers, especially on the residential side, commercial has a lot more planning, but a lot of residential customers are like, hey, I finally got my land, I finally got my money, I finally got all the things I need. I want my building right now. And if you're like, okay, we can get the process started, but even if we get a deposit today, it's still going to be 12 to 16 weeks versus the guy next door who's like, well, I can get you your building in 3 to 4 weeks. That's a huge, huge advantage. So I think it really fits. And again, it's not going to be for your Walmarts and for your Costco's and those type of structures. But for the smaller commercial buildings and then for pretty much every residential application, they fit that need really, really well, and I think complements and can fills out the scope of work that an erector and a distributor and a manufacturer can serve pretty easily. So some long-term benefits of cold form are like metal metal buildings in general. You have less maintenance. You're not worried about rotting. You're not worried about warping. All the framing on the cold form buildings that I get are all galvanized. So you're not worried about rust. Yeah, it's just less upkeep, and you get all the classic benefits of a PEMB. So insurance is going to be another one that we've seen be a benefit more and more in recent years. Again, partially due to the wildfires here in Colorado as well as California. So in insurance companies, they're always looking to limit their liability, right? We've seen a lot of major insurance companies, they're actually not even putting out for new homeowners policies in California anymore because of all of the payouts they've had to have due to the wildfires. And so having a building that's built with non-combustible materials makes a big difference for that. And usually, if you're doing a fully metal framed components building, you see about a 15% decrease in insurance premiums. And in some cases, it can even be higher than that. And in some places, if you're really kind of out there and in a high fire risk area, you may get rejected entirely. So again, here in Colorado, we built a couple barn dominiums this past year, and one of them very specifically, like he had everything going on a wood frame, and then or his whole idea was wood frame design, and then the fires over by Gunnison started, and he was like, nope, we got to switch to metal. And then he came to us. We were able to get everything engineered what it needed to be with the deflection limits, the collateral loads, because he was over about an hour away from where those fires were, and got the cleared with insurance. And we were still able to get, since it was a cold form building, we were able to get it on site very quickly. He didn't have to massively adjust all of his other plans and push all of his trades back like he would have if it was more of a hot roll building, just because it takes longer to produce in the manufacturing plant. Like it just fit that need very, very well. And he's yeah, he's a good example of that. And then going into easy to update. One of the things that I do really like, if you kind of see in, this would be the left corner of that picture here, that column, and you notice that the columns on cold form buildings, both the main columns on your mainframe portals, as well as your end wall column, your more supporting columns, are all going to be straight. There's no taper to them. Now, you may have some taper at the top for a knee brace at certain areas, again, depending on what your snow loads are and all those things. But the main column itself, that piece is going to be straight. What that means is it's a lot easier for someone to finish out on the inside. Makes it even better usage for those barn dominium clients. And even, office spaces and the business parks and for storage units. I've built a few interior, like fully enclosed storage facilities for RVs. And, RVs, you're looking at 14-foot high, some of them even bigger if you get into the really big stuff. And you start tapering in more and more and more the higher you go, and you start losing those clearances. You means you have to get more square footage. You have to bring out your bays more. The investors for that facility are now having to spend more money and allocate more space per bay, which changes their payouts. If it was straight all the way across, you can narrow those in. It just makes it more attractive for those reasons as well. But the finish out on them is great. And then again, with ability to have the full engineering changing deflection limits and even collateral loads, you can put drywall if you change your spacings on your girts to what you need it to be. You can even do drywall just right to the inside of your girt faces, and you don't have to worry about it breaking. So, very good thing for the interior finish out.
Cool, cool. So built to last. I think a pretty self-explanatory slide, right? I know we've mentioned it multiple times now. These are, pre-engineered buildings, right? So buildings are going to be around a lot longer than we are. I think most of you are probably familiar with your paint finish warranties provided to you by your manufacturer or your manufacturer's paint supplier, et cetera, right? We know those, are pretty significant in nature themselves, right? But these structures are designed and built to the local code, specifically where the building is going. So again, they'll be here much longer than we will. And then a growing opportunity, right? So we've seen cold form, really the cold form space grow at a clip of greater than 50% now for the past few years. I don't forecast that slowing down, right? I think we're seeing more and more erectors and dealers understand the advantage of really where cold form buildings are best suited, right? And then how they can continue to successfully supplement that growth within their businesses, which I think is really important. Some of those folks are choosing to push more to cold form. Others are, again, back to understanding, how many rigid frame buildings versus maybe some gaps that they've got that they can leverage, and go erect some cold form buildings as well. We're starting to see that, or we're continually seeing that improve year on year. Additionally, buyers, right? I know Nathan talked about it. We're all aware everybody's looking for something customizable as well as economical. But I think what's really important, as Nathan mentioned, is people are looking for something right now, right? That's just kind of the world we live in. Somebody wants to point, click, and have it on their doorstep the next day, probably thanks to Amazon, right? So I think Cold Forms fits that model obviously very well, given the fact that the manufacturing process, given the fact that you can turn these buildings pretty quickly back to manufacturing. Uh, Again, I think mentioned in previous slides, it prevents a significant opportunity for manufacturers who already have or are planning to invest in roll formers. Those roll formers, I know that if you haven't seen one, that there was a small picture of it, requires a significant or a sizable investment of capital, right, for manufacturers. So most already have roll formers on the floor. Cold form buildings, a perfect opportunity, obviously, keep those lines at max capacity while servicing these buildings and continuing to grow and scale within the cold form building space. So that's really all I've got. I will go ahead and open up the floor for questions, Sasha. If you want to kick a few out here, we'll go ahead. Anything in particular as well? I guess I will preface if it's act specific or maybe not more specific questions, feel free to email Nathan and myself. We're more than happy to follow up with you and make sure that we respond to those.
So we do have a question from Jared. Jared, if you want to unmute and just ask your question, that would be fantastic.
Yeah, I'm curious. I've been looking at these for just like you guys say, kind of ancillary buildings to our metal building systems that we're already doing. Typically for like really small storage shed kind of things, but obviously a little bit larger than a shed, but not quite a full metal building system. But like for our standard buildings, typically like the space spacing and spans, they kind of sort of I put it in quotes like they like to be at around 25-foot base spacing between main frames and typically clear spans of 100 foot or less. And I apologize, I showed up a few minutes late as usual. But I don't know if you could give us some guidelines, like what kind of base spacing do these things typically like to like? What's the most economical kind of standards out there that we could kind of base things on as we're thinking about and looking at these things for our clients?
So I'll lead off from a general response to that, Jared, and then Nathan, maybe you speak to specifically kind of what you see in the Colorado market. I guess Jared, kind of nationally, right? Cold form buildings, it's going to change. It's everything. I guess what's going to dictate that design is going to be what your snow load is, right? What is your wind speed with these buildings? That could take something that, more functional within that 20 to 25 foot. You start adding some pretty sizable snow load, you might see that base basing tighten up to 10, 12 feet, right?
Right.
A lot has to do with manufacturing capability as well, right? If a manufacturer is running, let's say, a 12-inch C purlin or maybe something smaller versus a manufacturer that can produce a 20 or 24-inch, that also is going to impact what that design potential is. So, Nathan, I don't know if you want to speak a little bit more specifically to what you might see from a trend standpoint on a regular basis, but that might put a bow on it or at least help answer that question.
Yeah, absolutely. So what I see a lot in Western Colorado, I'm excluding the really high up, like we're building a barndominium in Granby right now, and that's obviously way higher snow loads. But what a lot of what I see in in areas where we're hitting like a 25 to 40 pound snow load and about a 95 to 120 mile per hour wind speed, just to give some specific reference, is between 15 and 20 foot on the base spacing seems to be the most economical. The manufacturers that we work with a couple, are pretty capable to making it kind of however we want it to be. So you kind of got to play around with it in your specific area and what your specific needs are to find out where that price point is because it'll engineer in multiple different ways, right? But for us at those wind speeds at those snow loads, which is what the bulk of our buildings fall under. Between 15 and 20-foot base spacing seems to be the best bang for our buck for material as well as erection. Because sometimes they're like, oh, well, we can use smaller, lighter gauge components, and then your base spacings are like 10 feet, right?
Right.
But then, 10 feet to 20 feet, you've got double the columns, double the rafters, double the pearls of the grid, double everything to install.
All right.
So
So what about the overall like clear span widths and things like that? You guys are typically around 50, 60 feet. I'm just guessing, but
yeah.
I'm in Cleveland, Ohio, so very similar to your less snow loaded buildings. Our snow load here is like 25 to 30 at the high end.
Yeah.
And I think they just moved to 115 wind load over the
Okay.
past year or so.
Yeah,
So
so that's
pretty
very
similar in that kind of thing.
yeah, I'd say for clear span, we typically when we start hitting the 65-foot clear span, that's when we start cross-checking over with hot rolled and red iron manufacturers that we go through. That's where we start looking at them and seeing what that pricing comparison is. 9 times out of 10, if not more, if it's under that, the cold form beats out on price in material. Yeah,
I have a question.
please.
Sure, go ahead, Art.
Okay. I see a lot of talk about being out west. Is there anybody here that can talk about what happens in the eastern part of the country? Manufacturers or the use of it, acceptability here?
Yeah, so I guess, or to answer your question, historically, and I'm probably going to be a little long-winded here. Historically, cold form really grew quickly in the western part of the U.S. into the central part, right? If I go back and rewind 15, 20 years, that's where we really saw it grow roots. From a manufacturing standpoint, and what we're seeing as of today, we've got a number of manufacturers, a lot of buildings going either into the southeast, northeast, you name it. So it's gaining popularity without question. I'm from the southeast myself, right? So my I say it often. It's usually like if it ain't broke, don't fix it here in the southeast, right? It's a new thing. So it's one of those back to I know Nathan mentioned on making sure folks are trained up, not only how to erect it, but how to position it within the market because we know we've got post frame, we know we've got tube steel to compete with and deal with, and how do you angle cold form in that space. But again, I think when we go start talking about the advantages of it's a pre-engineered building, if somebody's looking for that really seems to do the trick, understand how to, how quickly it's going to turn around, et cetera. But again, to answer your question, very common in the eastern half of the US, and we're starting to see that continuing to see that pick up.
Okay. I noticed in some of your pictures you have self-drilling, self-tap connections, but you also have some bolted connections. Are the bolted connections pre-punched?
They are. That is correct.
Okay.
And then even a lot of the self-tap screws, if those were a little bit older pictures, or maybe they're still newer ones, but in like the software that I used to design the ones that we make, or not make, but that we sell and then put up, you have that option to do you want to do this as as a fully bolted building? Or do you want to have the main members bolted together and then all your secondary framing, all your girts and purlins screwed? So you actually have that choice a lot of the time for whatever the erector prefers.
Okay.
And if you go with the fully bolted, then the purlins and girts and everything is pre-punched as well.
And it's pre-cut the length, pre-miter cut and everything.
Yeah, the only times I've seen components coming out where they're not cut to length is if they're really short, like you got like two windows next to each other and you got a girt that's like this big,
Right.
you got a 10-inch girt or something. That I've seen those. If you say you got three of them, I've seen that being sent at like a 30-inch piece that's kind of perforated, and but it's even so it's not cut all the way, but it's kind of notched in where you can either cut it very easily with whatever you want to cut it with, or a lot of times I even just bend them and just split them apart that way. But they're still identified separately as independent components, which is really really good. So you're not having people grabbing that thinking it's something else, and then it's just like an inch too short or whatever it might be. But that would be the only time where I've seen the cold form components not coming fully pre-cut.
Okay. And do they jet print part numbers, part IDs, or connection points?
Yeah, yeah. So you'll have in the detailed plans that Cameron had mentioned earlier, it'll specify you'll have, your component schedule, right? Just like you would like an opening schedule. It'd be like a CLB_1, CLB_2 for like your different columns, for example. And then you can go and it's usually on the inside channel of that C channel. That's all printed out. And yeah, so like what we do is when we're offloading material is we just take and we do this whether it's a hot roll building or a cold form building or whatever it is. When we're offloading the building on site, we kind of not take everything apart 'cause you don't want trim flying around everywhere. But we take the framing and we inventory everything, and yeah. But the manufacturers, at least the ones that I've worked with, they do label each individual component.
Do they label the parts for connections? I mean, do they lay out, say, when you had that overhang and you're putting those rafters in, do they jet print where each one goes, or is that something you lay out as if you're doing conventional wood framing?
Uh,
Uh-oh.
Oh, wow. Art, I'll answer that. Like it would depend,
I guess
obviously
I guess that's a no, huh?
on software. Usually, I guess what I'm experienced with, it's usually going to call out a rafter connection. It'll call it out on plan. It's going to be pretty typical. I will expand too on your cutting. There is some minor, just depending on construction type, right? Cold form is broad, but some construction types you would have some cutting. I know I showed that knee brace. You also have an apex brace. There would be minimal cutting right there, where you would miter that section, but generally speaking, minimal.
Okay.
what happened?
We
We
got
lost you.
we got you.
Oh, I'm back.
You're
You're
back.
back.
Yeah, yeah, yeah. Yep.
Sorry about that, guys. I don't know what happened there. I can't see anybody, but if you can see and hear me, then I think we're okay.
You are okay.
Okay. Yeah, my apologies.
It
Uh,
happened.
but to answer your question, you use the combination of the drawing and the schedule on the plans and what is marked on the individual components to come to that conclusion of this connects to this. Yeah.
So with metal buildings also, we're seeing a lot of alternate wall panels and alternate like a third party or outside manufacturer do some, custom things and like exterior dress up stuff in the metal building world. Are you guys seeing a lot of that similar thing on like the residential side where, local home ownership HOAs and things like that will require vinyl siding and all that kind of fun stuff, or like different cities for permits would require a specific panel type or a faux brick or something? Um, do you guys have pretty good systems for handling those kinds of alternate wall panels?
Uh, I'll speak as I said from a manufacturer standpoint first. Boy, I wish we could just all sell a whole heck of a lot of PBR, right?
Mhm.
But you're not wrong, right? I mean, custom is, we talk about it, and that's something that, everybody, especially now with the internet, everybody's become experts at finding everything. So it is very common. And Nathan, I don't know if you've got some specifics that you see on a pretty regular basis, but whether it's cladding, insulated panels, you name it, those are pretty common conversations or requests that Cold Form has no problem managing.
Yeah, I mean, I would say it's you treat it the same as you would as if it was a hot rolled. So whatever specialty product you're looking for, whether you're sourcing that from the same manufacturer, or if you're sourcing that from if it's very specialty from another source. Like here, we've got a there's a company out here in Delta where all they do is the specialized sheeting and trim. And so I can actually get the cold form building where it's just the framing and get all that engineered and everything that it needs to be. And then I can adjust my girt spacings or my purlin spacings or if I have to for that specialty cladding. And then I can get the building from them and I can get the whole exterior skin from somewhere else. And if you're running something like an HOA, or even some building codes where it's like, okay, we have to have this type of siding that doesn't work with horizontal framing like girts are, then my solution to that is you set your girts at 4 foot spacings. Now you can sheet the whole thing in your standard 4x8 OSB sheeting, and you can treat the whole thing as if it was a wood frame structure from the outside and do whatever you want, right? And then there's a couple other specialty companies out there that work with PBR profile where you can get that FA rock panel like you mentioned, or even the FA wood paneling or stucco paneling even, where the interior face is shaped to match that profile of your sheeting, and you can just wrap. So then you can sheet it all in PBR like you would normally, and then you come back after the fact and you install that. So yeah, it's whatever you can do with a hot roll building in terms of the exterior. I haven't ran into anything yet that I couldn't also do with a cold form building. And especially since you can adjust for those collateral loads, if you know you're doing that, say they don't want faux rock, they want actual rock, right? You can make sure you're adjusting for that on the front end. Um, so yeah, it's very customizable.
Okay, and Jerry put in a comment in the chat. So if anyone in particular
Yes,
is
yes,
interested
that
in,
was me. Yes, yes. I've been in this industry for 20 years, right? But I do not supply buildings. We do supply engineering for the things. So we're developing software for companies based in Australia and in the UK. And I have some, improved connections now. So my questions would be whether suppliers in the United States would be interested in some improved designs for the things. We're facing arguments from people from hot rod industry in terms of engineering because our connections are semi-rigid. And I saw your photographs where it's similar to what we do, and to respond to their request or these arguments, we developed something that's less semi-rigid, and we made a software compatible with the things and with those products. So my question would be whether there would be a manufacturer or a group of manufacturers who would be interested in the things, or where to go, where to ask, if you could recommend this. I have a presentation, some photographs that I can share or send you some documents.
Jerry, I guess I would respond and say if you had my email address, I don't know if you took that down, but I would absolutely,
Right.
when it comes to the space and the elevation of cold form,
Yes.
in the space, I think that's what we're looking to
The
achieve.
improvement is in some connections, especially column base, and these profiles they're very sensitive to any warping deformation, so we reduce the thing for little cost of this thing, and this solution shortens buckling length of the frame, so we can drop the profile sizes because of the things, and reduce the side sway of the building. So we have developed this engineering. I'm not in the United States. It's in millimeters, so I need to convert the things. So I have to come up with some different dimensions. But if you were interested in this, I would like to introduce the things.
We'd love to have the conversation.
Right. Okay. I get a contact with you, and we'll try to manage some session.
Perfect.
Right.
Looking
Okay.
forward to the
Okay. Thank
conversation.
you.
Yeah,
All right.
thank
Thank
you.
you.
Okay, we're going to wrap it up. Any final questions? We also have the contact information for both of them. If anyone didn't grab it, let us know and we'll get it to you. But we want to respect everyone's hour. And so, Cameron, you just kind of want to wrap up with the fact that you'll be at the conference, or
Yes,
someone will be.
absolutely. We will have representation there, and certainly looking forward to participating, being a part of the conversation. Again, thank you to the NBCEA for allowing us the floor today, and look forward to continue to work with everybody on how we can continue to improve and support the overall industry, the metal building industry going forward. So thanks everybody for the time. Thank you, Sasha.
Thank
You're
you.
welcome. And thank you, Cameron and Nathan. We appreciate this introduction, and we will see you all soon.
Yeah,
Thank
thank you
you for
guys.
having me.
Thanks, everybody.
Bye bye.
Bye-bye.